Hello, everyone, and welcome back. This is Dr. Sohal Barushaki, and in this lesson, we will be learning about NumPy module. We will continue working with NumPy in the next three lessons, really. So, what is NumPy, really? NumPy is a fundamental package for scientific computing in Python. And it offers support for n-dimensional array objects. I will be explaining today the basics of NumPy and NumPy arrays. And I'm going to talk about what are really arrays in NumPy and Python. And then after that, we will be learning about feature class to NumPy array function of ArcPy, and we will learn how to use it later on. So first of all, let's get started with this simple example. So as you can see, we imported ArcPy site package, we imported OS module, and I also imported NumPy module. However, this is the first time you see this structure. So I imported NumPy as NP. The reason is this, because NumPy has, in this case, 5 letters, and I just like it is much easier to work with that module with just the 2 letters. NP, it would be simple for a simplified version of NumPy. So I can import a module as with a pseudonym. So this is NP name for this module in this cell. So later on, instead of calling for NumPy module, I will simply call for NP, which will be referred to NumPy module. First, I created a simple Python list. And from lessons before, you remember that a Python list, I can create it with square brackets and elements within the square brackets separated by comma. So in this case, I have these elements here, and then I ask Python to print my list and give me the type of the list. However, this is the original way of creating lists in Python. This is, in fact, my a PyList. It will be a Python list. However, what is then NumPy array? You should think of NumPy array of lists with extra functionalities. Look here. I ask the NumPy module to create an array. So this is how I create a new array in NumPy. I would call NumPy create a new array, and in parentheses, I passed basically a list. This list looks exactly like my list here. So I create an array this way with array function of NumPy module, and I simply passed a list to this array, array function, and that would create a NumPy array for me. And then I'm asking Python to print my array and also show the type of this array. Let's execute this cell and then talk about the differences now. So I run this cell, and it is showing here that the first option is my Python list. It is showing this that this is my list, and the class or the type of it, it is a class of list. It is a list. It's a Python list. Then I created my NumPy array with array function of NumPy module, and it printed basically same sequence of numbers. And however, it is telling me that this is a NumPy array, and that ND is for n-dimensional array. I will talk about that. But in reality, you can see that they are very close to each other in terms of constructions. So for now, I just want you guys to think of NumPy arrays as Python lists with extra functionalities. And I will explain that in a second. So why we use NumPy arrays? Because NumPy arrays, they give us so much out-of-the-box functionality, so we can work with them much faster and easier. We work with NumPy arrays heavily in data science, and we use them in GIS. We use them basically, if you are in Python programming, you have to use them on daily basis, because NumPy arrays offer extra functionalities, making data science very simple, or data analysis and extraction. So look at this example. In this example, again, I imported my modules. Then I created a NumPy array the same way that we used it in this previous cell. Here is the question. If I have this list, what is the average of the numbers that I have within this list or sequence? I can use some functions in Python to calculate basically the average of these numbers in this list. However, in NumPy array, I have access to an extended list of mathematical and statistical functions, so you don't have to, in NumPy array, to write a function to calculate average, for example. I simply create my NumPy array this way, and then I would ask NumPy module to grab the mean of this array. So here, as you simply see that, I can call my module, NumPy module, and ask for the mean of this NumPy array and see what happens. And of course, I'm using fstring to insert that value here. So I simply can, without doing any extra functions or writing functions, I simply can grab the average of this sequence here. And I put for you guys here that simply we can have mean, sum. I can change this to sum. And of course, here it would be the sum. Actually, let's do this. Let's keep that one and go to a new line and do this. I can grab sum, and I just have to change the sum function. It would be the sum of the values within this array. And I also can get the standard deviation of, and it would be std here, of this array. So if I run this one, I simply can have access to all these statistical and numerical value of my sequence or my array in this case. So when we are using NumPy, instead of list, we are calling them arrays. However, what are arrays really? They are sequence of elements, number, values, which are in fact in order. So Let's look at this example. It is about this number of dimensions, or this arrays in multi dimensions. What do I mean by that? So there are in many cases in data science that we create, instead of one-dimensional data like a sequence, we have two-dimensional information or data. The example is here. Basically, I'm creating an array of these two elements, and as you can see, these two elements, they are themselves, there are arrays. So I'm going to go and run this line of code. Then let's go back and talk about their properties. So I'm going to run that. As you can see, it is showing me that this NumPy array in fact has two dimensions. Look at this. It has 1 and 2 rows, and it has 1, 2, 3, 4, 5 columns. And I have rows and columns like tables. So it can handle data that look like a table in a 2D array. I'm asking NumPy, just give me the dimension of this array that I just created. It's telling me that it's a two-dimensional array. And then I'm asking for the shape of this NumPy array. It is telling me that it has 2 rows and 5 columns. And we use this structure a lot in GIS. Why? Because my attribute table in fact is a two-dimensional array. I can consider it as a two-dimensional array. I have rows, and each row refers to a feature, and I have columns, and each column is in fact a field. So we use this property of NumPy array a lot in GIS. We use this property in raster data as well. Let's look at this example to see what is or what are the extra functionalities that make working with two-dimensional arrays much easier. So you just learned that I can, with passing lists or array within an array, I can create a two-dimensional array. And then I would be printing that. So let's do that first. I get exactly same array that I got before. However, sometimes often I would correct myself, I need to grab the sum of each field. Look here. The sum of this column or field is 9. The sum of this column or field is 14, and so on, right? Why we do that? Look at this example. I open my attribute table. I need to grab the sum of tax value 04. So there are ways to do that in GIS. I go to statistics and I grab the sum of only this field, which is a column. So in data science, we need the sum of our columns. Can we do that in using NumPy? Yes, we can do that. I simply go and ask, hey NumPy, give me the sum of this array. We did that before. If I just do that like this example, it would give me the sum of all values. However, here I will give my NumPy sum a second parameter, and that would be axis 0. And in axis 0, when I'm talking about an axis 0, I mean over columns. So, hey NumPy, go grab the sum of each column acts as 0 in this array. Let's run this and see what happens. And then it gives me another array that each element is in fact the sum of the columns. Here is 9, 14, 23, and so on. I also can get the sum over rows, which it would be axis 1. So in this case, I would go and pass axis 1. And if I run that, then it would add these values 1 plus 1 plus 2 plus 3 plus 5, 12. And these values, they would sum to 131. So NumPy arrays, they give us more functionalities, extended functionalities, and they make very easy access to n-dimensional or multi-dimensional arrays. In GIS, we heavily use two-dimensional arrays to get and extract information and data from, for example, from our feature classes. Okay, I will see you guys in the next video so we can continue learning about NumPy arrays in GIS. Bye for now.